Hi, this is Guntuka Srinivas. Welcome to Varenya's Photon Online Academy for IIT and NEET examinations. In this channel, we mainly concentrate on the basic concepts associated with physics, chemistry, and mathematics subjects for the IIT and NEET examinations. In this session, I welcome you all for IIT physics classes. In the previous physics classes, we have seen about speed and velocity, average speed and instantaneous speed, average velocity and instantaneous velocity. Clear? In this session, let us see some of the concepts associated with the graphs related to velocity. Let me take a graphs related to velocity. Clear? Before going into the details of the graphs, let us define velocity once again. What is velocity? Velocity is v bar, since it is a vector, v bar is nothing but displacement by time. Simple definition is displacement by time. Let us define the term average velocity. Average velocity, that is v bar, again to the vector AVE. AVE stands for average velocity, which is nothing but total displacement, by total time, total displacement by total time. Recollect, when do we use average velocity term? When there is a long path, journey is very long, the duration of time period is long, then we make use of average velocity term. Clear? And observe carefully. This average velocity, V average, can also be given as change in displacement by change in displacement by change in time. Mathematically, it is defined as V average, defined as change in displacement, delta. Change means delta notation. Delta S by delta T. Delta stands for change. Change in S stands for displacement notation. We adapt year afterwards. S for the displacement and T for the time. Delta S, change in displacement, by the delta T, change in the time. Clear? Sometimes we can notify this, we can indicate this also like delta R bar by delta T. In the previous sessions, we have noted wherever there is a position vector, we have taken there directly, we have taken that R bar is the change in displacement. Delta r bar is the change in displacement. So that in terms of the vector notations directly, in terms of position vectors, you can adopt this and also this. Clear? So year of traverse, average velocity is delta s, change in displacement by change in time. Clear? Now, observe carefully. We have also defined a term, instantaneous velocity. Instantaneous velocity, which is simply V bar. Bar stands for vector. Instant. This is for instantaneous notation, which is equal. We simply define as ds by dt. ds by dt. Instantaneous velocity is simply defined as ds by the dt. Here, what is the instantaneous velocity? Instantaneous velocity is nothing but velocity at a particular instant of time. At a particular instant. Be careful this term, at a particular instant. Clear? Suppose let us say that example here I am showing. Let us say your journey is from A to B. Let us say your journey is from A to B. Let us say you have traveled for total time of travel is 3 hours. Completely 3 hours you have traveled. Total time of journey is from A to B you have traveled 3 hours. Clear? Complete. Be careful. Total time of travel from A to B is 3 hours. Clear? I require velocity at 40 minutes. I'm locating the point. Velocity at 40 minutes, 2 seconds. Yeah. At this particular instant, be careful. At that particular instant, 40 minutes, 2 seconds, that is known as instantaneous velocity. Just for example, suppose if you require the velocity, at a particular instant of somewhere 2 hours, 22 minutes, 1 second, at this particular instant, that velocity at that particular instant is known as instantaneous velocity. That means instantaneous velocity is for a very, very, very small period of time. Very small period of time. Time period is very small. When there is a time period very small, the displacement is also very small, because truly speaking, there is no displacement at that particular instant. But for mathematically, we are taking it as very small time dt. In that small time dt, the displacement associated is ds. In the small time dt, the displacement associated is ds. That's why instantaneous velocity is defined as ds by t. Clear? Observe. Clear? Now, here I explain. Observe. Just now we have seen that velocity, instantaneous velocity, average is ds, change in displacement by change in time. change in displacement by change in time. Suppose if I need at a particular instant of time, if we need velocity at a particular instant of time, at a particular instant of time, then what is change in time? Change in time at that particular very small period, change in time tends to 0. When change in time tends to 0, automatically change in time is very, very small time period. We denote delta t. We replace that as with small time dt. D stands for differential element, very small time. Similarly, delta s in the small change in time, very small dt time. Delta s change in displacement is also very small ds. Hence, we are using delta s by delta t is replaced by ds by dt. Replace it by the ds by dt. That is the instant velocity ds by dt. At that particular instant. Yes, delta s becomes ds, small displacement, and delta t change in time is, as time tends to 0, change in time tends to 0, delta t becomes small time we have taken dt. D stands for very small differential element, small, and within the dt small time displacement is small ds, hence ds by dt. That particular instant of time, this is known as instantaneous velocity. Here afterwards, the formula ds by dt stands for the instantaneous velocity. Clear? Okay. Now we have defined the term. We have defined the term velocity, average velocity, and instantaneous velocity. Clear? Let us see the graphs associated with this displacement and time. Observe. Suppose here I write graphs related to velocity. Let us go into the graphs related to velocity. Clear? Now I am plotting a graph is plotted. A graph is plotted. Displacement versus time. Observe carefully. Graph is plotted. Displacement versus time. Clear? Displacement versus time. Now, observe. This is a graph. On the x-axis, time I have taken. Time t stands for time. On the y-axis, here I have taken displacement. Yes, displacement. This is the RS. So on the x-axis, time I have taken t. On the y-axis, I have taken displacement s. Let us say I have plotted a graph with the available data. Let us say a line OA is plotted with the available data of displacement and time. I have plotted a graph OA line here. That means we obtain a displacement versus time graph OA. We obtain a graph displacement versus time. Is it clear? Okay. Now, observe carefully. Here I am showing. This is x-axis. This is y-axis. This is origin. Clear? This is displacement. Yes. This is time t. Let us say I have plotted OA line. A graph of. Okay. Now, let us say this OA line is making an angle theta with respect to positive x-axis. Be careful about the word. OA graph, this OA line is making an angle theta with respect to positive x-axis. Here I clearly write. Here I clearly write where theta is the angle made by OA line. This line itself is a graph. Bracket I am putting graph OA line with respect to positive x-axis. Positive x-axis. OA line is making. OA line is a graph. Line obtained is a graph with the available data of S and the T with respect to positive. Be careful this word. Theta is always measured with respect to positive x-axis. Clear? Okay. Now, what is the slope of this OA line? Slope of this OA line. I am interested in the slope. What is the slope of this OA line? Slope of this OA line is theta. Clear? Slope of this OA line is theta. So here I mention theta is equal to slope of OA line. That is slope of the graph. Bracket I am putting slope of the graph. OA line is a graph, so slope of the graph. Clear? Theta is nothing but the slope of the graph. Okay. Right? Now, observe mathematically, here I show. Suppose this is x-axis, this is y-axis, this is origin. If you have a line, OA, and mathematically, what is this slope of this line? Slope of this line. Let us say this is the theta is the angle made by the line with respect to positive x-axis. So as I said, theta is slope of graph. But mathematically, what is the slope? Slope is equal to. How do we measure? This is the slope. Theta, this is the slope. Slope is y2 minus y1 by x2 minus x1. This y2 minus y1. Observe y2. Suppose the coordinate here it is y2, and here it is. This is y1. So this here I am giving a notation. The notation I am following is BCD triangle. Simple BCD triangle. Theta is the angle. Okay. CD is tan. Slope is tan theta. Slope is tangent theta. Opposite side by adjacent side. Opposite side CD by the adjacent side BD. So CD is y2 minus y1. y2 minus y1. And BD. BD is observe. This is x2 and this is x1. So BD is nothing but x2 minus this x2 minus x1. So that is mathematically the slope, which is nothing but slope is tan theta, which is equal to tangent of theta. Slope is tan theta. In this triangle, tan theta. BCD right angle triangle, tan theta is the slope. Mathematically, y2 minus y1, difference of y coordinates divided by x2 minus x1, difference of x coordinates. That is slope. Slope is tan theta, tangent of the angle, tangent of the angle theta. Tan theta. Here, no. Observe. Slope, which is equal to change in y coordinates. Change. Can I write mathematical like this? dy. Change in x coordinate. dx, which is equal to tan. That means in mathematics, slope is tangent of the angle theta, which is defined as dy by dx. This is the formula. dy by completely dx. Change in y coordinates divided by change in x coordinates. The same formula here I'm applying to the displacement versus time graph. Same this formula I am applying to the displacement versus time. Observe. Suppose this is y-axis, this is x-axis, this is origin, this is y-axis. Suppose displacement is given on y-axis, time is on the x-axis, and we have drawn with the available data of displacement and time. We have plotted a graph OLI. And theta is the angle made by this line with positive x-axis. Then, how do we write the slope? Just now, applying dy by dx to this s versus t graph. Slope is equal to dy by dx. dy by dx is y2 minus y1 by x2 minus x1, which is equal to tan theta. Now I am applying the same thing to this. On y-axis, what is there? This s displacement is there. That means in place of y2, s2. In place of y1, s1. And in place of x2, t2. And in place of x1, t1, which is equal to tan theta. This is nothing but slope. Now, slope, I define s2 minus s1, change in the y coordinates of displacement. We can represent as ds, like dy by dx. We represent earlier. Similarly, this s2 minus s1 is represented as ds. T2 minus T1 is represented as dt. Here, this is nothing but slope tan theta, tangent of the angle theta. Here, now what is the slope of this? Slope of this s versus t is what slope? ds by dt. What is the definition of ds by dt? Just now we have seen velocity. So it is velocity. V bar velocity. Here, that means year afterwards, if a displacement versus time graph is given, The slope of that displacement versus time graph is nothing but velocity. Clear? How the clarity. So I clearly write here the slope of displacement yes versus time t graph gives velocity the velocity v bar which is equal to ds by dt, which is nothing but ds by dt. This is the plan. Now the clarity is displacement versus time graph. The slope of displacement versus time graph is nothing but velocity, ds by dt. Very standard fundamental aspect. Wherever s versus t graphs are given, you can directly calculate the slope, and that slope gives the velocity, which is ds by dt. Is it clear? Okay. Now, observe carefully. Here I am giving a simple graph. X-axis, y-axis, horizon. Okay. This is the graph OA. This is the graph OA. Clear? This is the graph OA. And the angle made by this line with positive x-axis is theta. Angle made by this line OA with positive x-axis theta. Let us say on the same I am drawing another line, another graph OB, and its OB line is making theta 2 angle with respect to positive x-axis. And be careful that on the y-axis displacement, on the x-axis time. Displacement versus time graph. OA one graph making theta 1 angle with positive x-axis. OB is another graph making theta 2 angle with positive x-axis. Clear? Now the class. Now, theta 1, theta 2 indicates what? Slopes of the lines. Tangent of theta 1, tangent of theta 2 give the slopes of the line. Which line is having more slope? Which line is having more slope? Observe, theta 1 is more or theta 2 is more. In this case, theta 1 is more than theta 2. Theta 1 is more than theta 2. Clear? Theta 1 is more than theta 2. And when theta 1 is more, slope of OA line is more than the slope of OB line. When slope of OA line is more than slope of OB line, velocity of what is slope? Slope is nothing but velocity. Velocity of OA line is more compared to the velocity of OB line. Clear? How the clarity? How the clarity? Be careful about this statement that when more the slope, more the slope, more is velocity, more the slope, more is velocity. Yeah, OA line is having more slope compared to the OB line, hence more the slope, more is the velocity, because displacement versus time graph slope is nothing but velocity. Okay. Now observe, this slope may be positive or sometimes maybe negative also. It may be positive or sometimes negative also. Because what is slope? Slope is tan of tangent of theta. Now here I am sure. I would like to show simple graph. Example 1 I am showing. Example 1. Observe. This is x-axis. This is y-axis, horizontal. So on y-axis displacement, on x-axis time, and x-axis time. Okay. Now, just now we have taken, this is OA line. This is OA line. This is the theta. This is the theta. Another example I show here is another example here. Example 2. This is x-axis. This is y-axis, horizon. And this is displacement on y-axis, time on x-axis. Okay. Let us say this is the line. This is the line. Graph is like this. Graph is like this, falling down like this. In the example 1, graph is like this. Be careful. In the example 1, graph is like this, and theta is this with positive x-axis. In the example 2, graph is like this. Graph is like this. Theta is this one with positive x-axis. Clear? Now observe. This is the theta. This is the theta with positive x-axis. This is the theta. Clear? No. What is the slope in this case? What is the slope in this case? Slope is equal to tangent of theta, tan of theta, tan of theta. Okay. And theta is the angle made with respect to positive x-axis. Be careful. Always I am using the word positive x-axis. Positive x-axis. As long as since theta is less than 90 degrees. As long as theta is less than 90 degrees. 90 degrees. Okay. Slope is positive. You will get positive slope. You will get positive slope. Slope is tangent of this theta. And theta is less than 90 degrees. So as long as theta is less than 90 degrees, tan of theta is always positive. When tan theta is positive, that means slope is positive, velocity is also positive. Because slope of ST graph is velocity. Velocity is positive. Velocity is positive. Be careful about this term. Clear? Now, coming to this here. Clear? Now, what is the slope in this case? Slope is equal to tangent of theta, tangent of theta. And observe carefully, tangent of theta, observe carefully. Since theta is greater than 90 degrees, always with respect to theta is with respect to positive x-axis. This theta is greater than, this line is making theta with positive x-axis. Theta is greater than 90 degrees. Greater than 90 degrees. Be careful, greater than 90 degrees. When theta is greater than 90 degrees, then slope is negative. Tan of that greater than 90 degrees, slope is negative. When slope is negative, what does indicates? Slope is nothing but velocity. So when slope is negative, velocity also negative. Velocity is negative. Velocity is negative. Here? No, observe carefully. As long as graph is like this, as long as graph is like this, theta is like this. Okay. As long as graph is like this, theta is like this. Theta is less than 90 degrees and slope is positive, velocity is positive. But if the graph is like this, theta always measured with respect to positive x-axis. Theta is more than 90. When theta is more than 90, tan of tangent of theta, you will get negative value. That means slope, you will get negative value. When slope is negative, slope of displacement versus time graph, S versus T graph is negative, then velocity is also negative. Velocity is also negative. Clarity. Slope positive means velocity positive. Right. Condition is theta is less than 90. Slope negative, velocity is also negative. Condition is theta is greater than 90. That's why it is very, very important to observe the graph. Observe the graph. Now, I generalize. Whenever you get a graph like these lines, theta is theta. This is theta, theta. This is theta. Theta is always less than 90. Then slope is always positive. Then velocity is always V bar. Velocity is positive. Clear? When you get a line like this, when you are getting a line like this, okay, and this is the theta, this is the theta. Theta is always more than 90. When theta is more than 90, slope is negative. Tan of that more than 90 degrees, tan theta becomes negative. When slope is negative, velocity is also negative. This is the observation. That's why you have to observe the graph. Is it clear? I hope you have understood the concept carefully. If graph is like this, theta with respect to positive x-axis, then tan theta, tangent of the theta is positive, slope is positive, velocity also positive. If graph is like this, theta is this with respect to positive x-axis, theta is more than 90. When theta is more than 90, automatically tan of the theta it becomes negative. That means slope is negative. When slope is negative, S versus time graph slope is velocity. Hence, velocity is also negative. Clear? So, observation is very, very important in getting a conclusion from the graph. Clear? Hope you have understood the graph, displacement versus time. And displacement versus time always gives the slope all S versus T always gives velocity ds by dt. Clear? If you like the video, please share it with your friends and encourage the channel, subscribe to them. Thank you very much.